Is this on?
I was wondering what that was.
Yeah, I think it's fun.
Good morning, everybody.
Hey, good morning, everyone. I'm Peter Bowen. I'm the VP of Technology over the Customer Data Platform at Tealium. We're a mortgage company, and we're here today to talk about Tealium configuration. Specifically, what happens when you treat it with the same engineering discipline that you would treat any of your other production systems.
And I'm Brian Goodrich. I'm the SVP over lead data at Pennymac, and the customer data platform sits within my portfolio. What we're sharing today started as a compliance requirement and turned into one of the more genuinely useful things we built working with Tealium. We have 3 demos and a lot to cover, so let's go ahead and get into it.
All right, so a quick bit of context before we get started on who we are, because it shapes everything about how we approach this problem. Pennymac was founded nearly 18 years ago to stabilize the housing market by helping people to stay in their homes. The financial markets were facing many challenges. A major investment bank had just collapsed, another was on the verge of bankruptcy and failure, and the housing finance giants were being taken over by the government. Our founders built something new. Pennymac has since evolved from a servicer of non-performing loans to a top 5 mortgage servicer and a top 3 mortgage lender. With $2 billion in revenue last year, and we service over $730 billion in mortgage loans, that scale changes how you think about every system you run, including Tealium. That scale comes with scrutiny. In 2014, non-bank servicers handled about 35% of all of the agency-backed mortgage loans. By 2024, that number was 66%, nearly double in a decade. And as the second largest servicer and the largest subservicer, we're a significant part of that shift, and it hasn't gone unnoticed. We're not telling you this to be dramatic, we're telling you because it shapes how we run our systems. Regulators, investors, and rating agencies are watching our operation controls very closely. Not just our financials, our change management, our data infrastructure, our audit trails, and in that environment, auditability isn't just a nice to have, it's non-negotiable. On the technology side, we think about hygiene. If there's not decay in a system, outdated configurations, undocumented changes, settings nobody remembers why they were set that way, we want to find it early. Not during an incident, not during an audit. Tealium is the backbone of our customer data platform, managing hundreds of attributes, visitor, event, and visit, all through the Tealium UI. Every attribute, every enrichment, every audience maintained manually in a browser. At that scale, it works. But when every change needs a documented owner, and approved and a rollback plan, the UI alone stops being sufficient. Brian lives with that every day.
Thanks, Peter. So here's what change management looks like in a regulated financial services company. Every change that reaches production has to have a trail. Who made it, what they changed, when, why, and who approved it. No exceptions. At year end, an independent third-party audit goes through that history. They're not just checking that the process was documented, they're checking that it was followed. They want to see evidence, approvals, change records, separation of duty, QA artifacts, all of it. You probably have some version of this at your company. The question is how much of your Tealium workflow figures out a way to live inside that SDLC process? How much of it's happening outside of it in the UI? Tealium gives you versioning and revision history and a save publish workflow. And if you really need it, the ability to roll back. For a lot of organizations, that's exactly what you need. For some Tealium use cases, that's exactly what you need. For us, we needed more. We needed field level diffs, not just this attribute was updated, but here's the before and here's the after. And we needed to be able to package it. We needed peer review changes before they go live. We needed cross environment production we could trust. And we needed a rollback history that doesn't expire after 90 days. The direction we landed on was extend what Tealium already does by treating configuration the same way that we treat application code. Not replacing Tealium, building a governance layer on top of it. Peter, let's get specific.
All right. So the first is field level diffs. Tealium's version history actually gives you quite a bit and it shows which Tealium item changed, what the type is, and who changed it, and when they changed. You can compare revisions side by side and see which items were changed, updated, or deleted. What it doesn't show you is what specifically changed within an item, which field, what the old value was, what the new value is. If audience membership dropped on Tuesday and you're trying to figure out why, Knowing that lead score final was updated by Jay Smith at 2 p.m. gets you a pathway there, but you still need another way to see the actual before and after. Second, concurrent editing. Tealium does have a concurrency model. Users get notified when things change, and it can reconcile non-conflicting changes. But when two people modify the same thing, Tealium says, hey, work it out together, figure out how to fix it. So this doesn't really work for us in some ways because that kind of coordination is operationally risky, and we want to make sure that we have good consistency. The third thing is cross-environment promotion. So the copy profile tool is useful, and many use cases support that. But we also found that it requires careful setup, verification. Sometimes it can overcopy, sometimes it can undercopy. And sometimes you bring over things that you didn't mean to bring. It can drop values. In a regulated environment, a promotion method that requires extra discipline is a weaker control than we needed. Fourth, there's no connection to external governance. No way to require a review before a change is published. There's no CI/CD integration. There's no audit trail that lives outside of Tealium's own UI. And the revert window is 3 months. These were design choices. They weren't flaws. Tealium designed it this way because it works for most of their clients. And that's fine. We're just a little bit different. And so we're going to show you what we did and how we do it a little differently. So let's go ahead and see the video from Luciana.
Hi everyone, my name is Luciana Vichutek Pedroni, and I'm engineer on the CDP team at Pennymac. I'm sure you are all familiar with this screen, so I will skip the tour. I want to show you what's happening under the hood when we load the Tealium profile. For that, let's open DevTools and go to the Network tab. Bear with me, this is an interesting part. I will go ahead and refresh the page. We can see several network requests. Let's search for a specific one, the profile one. Here it is. This is the Tealium profile endpoint, and it loads everything we see on the UI. Let's open it. Here we can see the profile endpoint. Let's go to preview. And here we can see all the elements. For instance, we can see account, actions, audiences. Let's see connectors, data sources also. Down here we can see quantifiers. Quantifiers are attributes on the UI. And transformations, which are enrichments on the UI. Let's go now to the raw response. I will copy and paste it into a text editor. We can see that this is a giant JSON blob file. If we go all the way to the top, we can see here account, actions, and so on, as we have just seen. Okay, now I want to choose one attribute from the UI to show you the correlation between UI and JSON. Let's use the Zillow listing attribute. It has ID of 5330. Let's search here in the JSON file. I want to search the one that starts with ID. Here it is. This is an object inside of the quantifier array, which is the attribute array.
It's got our own name.
We can see here information such as a name, Zillow listing, type, visitor badge, and other information such as transformation IDs. Transformations IDs, as I mentioned before, they are enrichments on the UI. We can see that Zillow listing has 2 enrichments. So the transformation array here has 2 IDs. That's interesting for us to analyze and observe that the way the elements, they correspond to each other in the JSON file is by their ID, is not by their names. Because of this, it's not so easy to find the elements inside of this file, JSON file, And it's also not easy to compare the JSON file between two different profiles. And this is the problem we are trying to solve, and Michael will show you the solution we built. That's all from my side, and now it's back to you, Peter and Brian. Thank you.
All right, thank you. What Luciana just showed you manually, that's the Tealium profile JSON. Every time that you open up the Tealium configuration, every time you log into the admin console, that's the same endpoint the browser calls every time you pull it and displays it on the screen. You've just seen it by section, but it actually pulls the entire profile every time. So that's the beginning. One GET request, entire configuration comes back as a JSON blob. So the first thing we built was utility that automatically calls that endpoint. So whether we're in our sandbox, our QA, our stage, or production environment, it handles the authentication, it pulls back the values, strips the sensitive values before anything touches disk, and then stores each environment separately so you can compare them. One command, and the retrieval step is the foundation that we built everything else on. So here's what the blob actually contains. 6 main types of configurations: your attributes, your enrichments, your rules, your connectors, your audiences, and any custom functions. The challenge is how they reference each other, which she pointed to on the screen. They don't use names, they use numeric IDs, and those change from profile to profile. So a transformation that sets a visitor attribute doesn't say the attribute's name, it says its ID number. And the audience definition doesn't name the rule it depends on, it references just that ID. So to trace through dependencies to understand which audiences are affected, if you modify an attribute, you have to do a file search manually for those IDs. At that scale, that's painful. And it's exactly the problem that becomes straightforward once you have the configuration in a structured files. So Peter built a solution to that.
Sure, the retrieval utility doesn't just download the blob, it decomposes it. Each attribute becomes its own file. Each enrichment, each rule, each connector, each audience, its own file, in its own directory with a name that reflects what it is. This is a change that makes everything else possible. With each component, its own file, you get a get diff that shows exactly what changed. You can review a single enrichment in isolation. You can search for every place the rule is referenced. The configuration stops being opaque. One thing that took care to get right is enrichments run in a specific order. The output of one can feed into the next. And when you decompose the profile, that ordering has to be preserved. We keep that ordering in a single separate file. Here's why that matters. If we embedded the position in each of the enrichment files, inserting a new enrichment would cause all of the other enrichments to move down, and that would cause a very large diff in the source repository. So you'd see hundreds of files, and it would mask what the real change was. The separate ordering file keeps the noise isolated, and your diffs stay clean and meaningful. Let's see what the system, let's see the whole system end to end. Let's hear from Mike.
Let's hear it from Mike.
Hey everyone, I'm Michael, a senior software engineer on the CDP team, and I built a lot of the tooling you're about to see. Luciana showed you the raw profile. Now let me show you what we do with it. We've automated this process to make it faster and repeatable. The tool you see running handles authentication automatically. SSO, session management, all of it. And before anything hits disk, it strips out sensitive values like credentials and secrets. Here's where it gets interesting. Instead of one massive blob, the profile is decomposed into individual files, one per component. Each attribute has its own file, named, organized, readable. Here's the visitor attribute we're going to work with today. You can see everything about it in the file that was created. We're going to promote this attribute from our test profile to our sandbox profile. The first big win of downloading the profile is version tracking. We now have a long-running log which allows us to see exactly what changed, when, and by whom. Add in commit messages and we can easily tie our Tealium changes to a Jira ticket, allowing us to close the change management loop. I'm going to retrieve the sandbox profile now to ensure we have the latest version. You'll notice it'll skip the authentication step, using the cached session from earlier. As you can see, the isFrequentVisitor attribute is missing from the sandbox profile. Here's where things get really exciting. You ever want to compare two profiles quickly and easily? There's a tool for that. We call it Tealium Maestro. This awesome tool tells us what was created, updated, or deleted in one profile, but not the other. No guesswork, no side-by-side scrolling through a UI. It outputs a structured JSON file containing what we call a change set. This is the change set file. It has some metadata about the change like source environment and target environment, and a list of operations. This is the forward change set, the exact operations to run. And every forward change set has a paired rollback. If something goes wrong, we run the rollback and we're back to where we started. Deterministic, every time. A change set is exciting and all, but what do we do with it? Even better, I'm now running Tealium Maestro in apply mode, where it takes that forward change set and applies it to the target environment. You can see it's utilizing the same session cache to log in. Now, it'll automatically navigate to the visitor attribute page, create the attribute, and even save the profile. We've also baked into the tool a verification process that checks to see everything was implemented properly. In this case, there's a validation error because we don't have AudienceDB enabled in test, but it's on by default in Sandbox. This allows us to ensure that our changes are applied correctly every time. Finally, I'll load our Sandbox profile to show you the attribute we just created. Clean, auditable, reviewable, every time. Back to you, Peter and Brian.
Thanks, Mike. So we got one more demo, and I want to give you a little context on this one. Evan is the newest member of our team. He's still getting up to speed on Pennymac, on Tealium, and on how we model customer data. He's only been with us a few months. So we gave him a task: figure out how our lead scoring model works using only the configuration file. Because now we got version control, and we can automate it. Now we're going to mine it. So here's what happened. Evan, let's see your video.
Hi, I'm Evan. I'm also an engineer on the CDP team, and I want to show you what becomes possible once your configuration is organized the way Mike just showed you. Here's a real example, our lead scoring model. It determines how engaged a visitor is based on their behavior on the site. There are dozens of interconnected files here, and without tooling, making sense of how they all fit together would take hours of manual tracing. Because these files are structured JSON in a repository, I can open them in an AI coding assistant and just ask it to explain what it finds. I'm not telling it what the model does. I'm only asking it to figure that out from the files. So watch what it does here. It's reading the quantifier files, following the ID references into the transformation files, and assembling a picture of the whole model. It traces the calculation chain from the 4 component scores all the way up to the final total. This is exactly the kind of cross-file dependency tracing that's painful to do by hand. Now here's the output. A complete, accurate description of the lead scoring model derived entirely from the config files. The 4 categories, the point values, the score bands, when totals update, and how those changes get sent to Snowflake at the very end. All of it from files, not from documentation that may or may not be current. Now let's go one step further. I'm asking it to turn that summary into a branded presentation using our company style guide. So it'll have correct colors, fonts, logo placement, all of it. Okay, now here it is. A fully formatted branded slide deck. It has Pennymac blue, Montserrat font, our correct logo, and it's built from the configuration files, not from a wiki page, not from a spreadsheet, but from the actual source truth. So this is what it means when your configuration lives in version control, not just auditability and change tracking, but the ability to treat your own configuration as a knowledge base. The AI can explain it, document it, and present it. And because the files are always current, so is everything it produces from them. Back to you, Peter and Brian.
Hey, thanks, Evan. Let's give a round of applause for Evan. All right, so here's where the project stands today. The retrieval automation is complete. All environments, full decomposition, authentication is all handled. We have a changelog, semantic versioning, an environment comparison engine, a change set specification, and a change controller with logging. Attribute parsing, and handlers for the full range of visitor attribute types, including complex ones like badge scoring and tally counting and enrichment rule automation. This is running production. It's not a prototype. It's a system that we use to manage our Tealium configuration today. Brian, where do we take it from here?
Where we're going. So broader attribute coverage. We're currently deep on our visitor attributes and expanding to get event and visit. Reliable environment promotions so we can move changes between environments confidently. Full CI/CD integration. Today we have a static analysis in the pipeline. We want to get to where you can automate the change application completely. And eventually self-service for marketing stakeholders where they can just request configuration changes that go through an engineering review before they're applied. The goal is a system where Tealium configuration is managed with the same rigor that we do with any other production asset, where anyone can, and the team can interact with it safely. One thing before we wrap up, and this one's exciting. There's something coming that's going to change the architecture of everything we just showed you. The new Tealium configuration API. Right now, Tealium has no write API for configuration, hence the puppetry work and all the automation through the UX. All the changes go through the browser. We built automation that drives the Tealium programmatically. It opens the profile, navigates the right section, makes the change, and publishes. It works, but it's as fragile as any other browser automation. It breaks when the UI changes, and it's slower than a direct call, and it's fundamentally a workaround. The new API changes all of that. Programmatic read and write access to configuration means we can replace all this browser automation entirely. Changes go straight through the API, faster, more reliable, and much easier to maintain. Full CI/CD integration becomes straightforward. The concurrent user coordination problem goes away. For us, it remains replacing a layer of our system with something cleaner. But for the broader Tealium community, it means the barrier to doing what we've been doing drops significantly. You don't need the browser automation. You go straight to the API, and the architecture we've described today becomes accessible to any team that wants it. We think it's going to be a real game changer.
All right. Thank you, everyone, for coming to our presentation.
And sticking through to the end of DV.
And sticking through to the end.
I know there's a few Ubers out there already, but any questions?
Yeah, we've got lots of time. So if you guys, this is a pretty exciting session, so we're going to let you go over if we have some questions from the audience. Back, we've got a mic, so give us a second so everybody can hear.
2 questions. What browser automation are you using, like Selenium or Puppeteer, Playwright?
We're using Playwright.
Okay. And then how long did it take you guys to do all this?
When Peter first came on board at the beginning of 25, this was one of the first problems I presented him with. He took it from there. This solution is all Peter's, and I just helped do a review on it, bounce some ideas off of, but I just gave him the shape of the issue, and he dove straight underneath the hood on the developer console and got after it. So to get to this point, Peter, you say it's taken about a year?
It's taken us about a year, but I think the question you're really drilling down into is browser automation is very fragile, and maintaining a browser automation project is almost a mission in madness, right? But the thing that's really been a game changer for us is using Cursor and AI development tools, because you can send the AI to go figure it out.
Yeah.
And if it gets it wrong, you're like, nope, do it again, do it again. And if you were going to send like an engineer or a junior engineer, right, their head would explode with how frustrating these problems can be. But the AI systems, they don't care. They just I don't say figure it out, because that's not true, but they just kind of work their way through it. And so things that in the past would not have been possible because of just how difficult and expensive they are coming back into the realm of affordability. And so that's, I think, the big key on this was being able to send the agents at it and then have them resolve it and solve the issues and work through it. Does that answer your question?
Yeah, absolutely. That was great. Thank you.
A case example would be is how fast Evan was moving through the presentation. The content of the presentation was not the point. The fact that you can make that presentation by mining your Tealium configuration as a knowledge base and then just generate it into a user-friendly, user-consumable presentation, that was the point.
And while we're talking about this, is everybody's runbooks up to date? So
I saw one hand.
One hand with up-to-date runbooks. One of the nice things about artificial intelligence and the agents is that it allows you to keep your runbooks up to date. So if you have clients, if you're consulting and you're trying to keep the configuration straight and be able to explain to them what's going on, at the end of each development cycle, you can have the agent kind of review and update the runbooks so that your documentation is always up to date, which is another task, back to what we were talking before, that was a very time-consuming and painful task that becomes a lot easier using the agents. Of course, you have to monitor it, you have to manage them. You can't just, take their word for it, but it certainly gets you there a lot faster.
Anyone else? Awesome.
We covered everything? Absolutely everything.
You got it all. You covered everything.
Hey, thank you, everyone. Have a safe trip home. Great DV, everybody.
Thank you, everyone.